Good morning, everyone. I am Gunnar Kalmeter. I'm part of the UCAR steering committee since many years. I've been asked to do this little video, educational video, to explain the new susceptibility testing categories S, I, and R, and the new concept of an area of technical uncertainty to be used in laboratories as a warning. So here we go. You can view this presentation on the UCAST website, or you can download it from YouTube together with other UCAST educational videos. The decision from the UCAST steering committee was prepared for 3 to 4 years before it eventually took effect on the 1st of January 2019. The decision was to change the definitions of susceptible, intermediate, and resistant to something different. The decision was also to retain the letters S, I, and R. That was following a long discussion about whether to change the letter I to another letter. Also to emphasize the strict relationship between breakpoints, between susceptibility testing categories, and the concentration or exposure, if you like, at the site of the infection. And also to task laboratories to absorb the uncertainties sometimes present in the testing and interpretation of AST results. We are using the term exposure in the new definition, and just to be absolutely sure that everyone is on par with what we mean, it's a function of the pharmacokinetics of the agent, the mode of administrating the agent, the individual dose, and interval between doses. So anything that goes into producing an active concentration at the site of the infection. This is the old definition of intermediate, the one valid until the last of December 2018. And as you can see, it has a number of components, some of which do not actually hang very well together. It talks about uncertain therapeutic effect. It talks about the concentration of the antibiotic at the site of infection, either because you could have increased the dose or because the agent is concentrated at the site of infection for physiological reasons. And it also adds the uncertainty of laboratory results, uncontrolled technical factors in laboratory testing. What it doesn't do is tell the clinician who receives an I as to which of these is valid in this particular case. So in our experience, many clinicians do not really know what to do with an I. And there are numerous jokes about what I might stand for. We want susceptibility testing to be respected. You can joke about other things. Uncertain therapeutic effect, that's UCAST's responsibility. There shouldn't be uncertainty about therapeutic effects if the breakpoints are right. Uncertain laboratory results, that's the responsibility of the laboratory. Not everything can be controlled, but if it cannot be controlled, then it is reasonable for us to actually own up to that and to admit that we couldn't be absolutely sure about the result. The concentration at the site of infection, which is a third component of the old definition, that's the clinical responsibility. So if you are told that you need to increase the exposure at the site of infection, there are a number of things you could do. You could go from oral to IV, you could go from IV injection to IV infusion, you could increase the dose, or you could decrease the interval between doses. But if you're not told when you should do that, you will not be able to respond properly. So the old definition of intermediate to the left, and the new category, susceptible increased exposure, to the right. And as you can see from the red text, the components of the new definition is actually reduced to one. Exposure to the agent is increased. So these are the new categories and the new definitions. S for susceptible standard dosing regimen, I for susceptible increased exposure, R for resistant. And just to remind everyone, exposure is a function of how the mode of administration, the dose, the dosing interval, infusion time, as well as distribution and excretion of the antimicrobial agent will influence the infecting organism at the site of the infection. This is where you find all this. You go to the UCAST website, you go to clinical breakpoints and dosing. At the top you have the breakpoint tables, 2019 version 9.0 in PDF format or in Excel format, depending on whether you want to print them or to have them on your screen. There is also a document called Dosing of Antimicrobial Agents. And that document really tells you what doses and what modes of administration goes with the two categories S and I. There is also an important document named What to Do When There Are No Clinical Breakpoints. So I advise you to go to this page and to study those different documents and familiarize yourself with the new definitions and the dosing tab. This is what the dosing table looks like. The agents in the left-hand margin, standard dose in the next column, high dose or high exposure, if you like, in the next column, and then at the far right, a column which lists specific situations and specific caveats that you need to have in mind when interpreting the dosing table. So this is the previous definitions, S to the left, R to the right, and something in the middle that we weren't quite sure what it was. And this is the new situation, resistant to the right, susceptible, two categories to the left, one for normal exposure and one for increased exposure. So we have to think about terminology because we can't use the term intermediate any longer. We can report we will report the bacterium as S, I, or R in our laboratory reports. No change there. We will say the isolate is S, I, or R to the agent in question when we talk to colleagues. We will say the isolate belongs to the S, I, or R category in speech. We might say that the isolate is categorized as susceptible at normal dosing or susceptible at increased exposure, or we might say that it's resistant, and we can use that both for speech and writing. We cannot call the isolate intermediate any longer. In the old days, there was a term non-susceptible, and that was used to describe isolates which were either I or R. That category, if it should at all be used, will in the future describe only resistant isolates. We might just as well call them resistant. In the clinic, there are some consequences of the new S, I, and R definitions. Agents with an I in the laboratory report should be considered a therapeutic alternative. And you need to consider then the need for normal or increased exposure depending on where the infection is situated. You will also have to get used to this year and even more in 2020 that some agent antimicrobial combinations where the species was previously reported S with a comment about the need for a high dose or high exposure will be moved to the I category to emphasize the need for high exposure. That will be from already this year Acinetobacter versus ciprofloxacin, Staphylococci versus ciprofloxacin, Pseudomonas. Next year, Pseudomonas versus most agents, maybe except meropenem. Enterobacterales versus cefuroxime, which are today labeled, categorized as S, with a comment about high dose, and the same goes for amoxicillin and amoxiclav. There will be consequences in the laboratory as well. When the I category was redefined, an emphasis was placed on the relationship between exposure and susceptibility. The methodological buffer of the I category was removed. So you could ask, are laboratories today so skilled at AST that methodological problems and the need for a buffer is gone? Yes, I think microbiologists have now realized that AST is in need of the same degree of methodological control as any other test in our laboratories, HIV, hepatitis, Borrelia, whatever. We need to include daily internal controls. We need to participate in external QA programs. We need to control what we do, and we need to be confident about our reports. Most of the time, it's not really much of a problem, provided we buy good quality stuff and use good quality machinery for whatever kind we have introduced into our AST testing. So here's one example of something that works fine. This is cefoxitin screening for MRSA in Staphylococcus aureus. You can see that the results are painted in the color of MIC values, and you can see that all the greens are to the right of the breakpoint and all the reds are to the left of the breakpoint, and there is no overlap in this test. It's a robust test which will give you the right answer 99.9% of the time, provided your material is fine. And if you want to check that, let's look at the MEC-A positivity and negativity, and you can see that that breakpoint will divide the population according to MEC-A status in the same robust manner as the MIC did. Here's a different test, meropenem 10 microgram disc versus MIC in a mixture of Enterobacterales, 378 different isolates, and you can see that the greens are to the right, the reds are to the left, and the yellows representing the I category are right where they should be. So again, a test without any significant problems. Another one, amoxicillin clavulanic acid with a urinary tract infection breakpoint of 32 milligrams per liter. Again, greens to the right, reds to the left, and very little overlap. A fairly robust and okay test, provided you have calibrated your own lab. However, on occasion, there is a need for a buffer. There are situations where there is variation in the method which is difficult to control. But more often, there is variation in the interpretation which is difficult to control. This may be because breakpoints split wild-type distributions, something we try to avoid. More often because breakpoint splits important resistant populations, which is more difficult to control. A typical example of the latter is the MRSA population split in half by ceftaroline and or ceftobiprole, and that makes for very difficult susceptibility testing and for poor reproducibility in results. The good news is that today we know much more about which interpretations are difficult and how to amend that. And for these situations, UCAS now introduces the ATU, the area of technical uncertainty. It's not a fourth susceptibility testing category. We do not reply to clinicians SI, R, or ATU. The ATU is a warning, an internal warning in the laboratory that your result, this particular result, has ended up in an area where interpretation may not be possible to guarantee. Also, importantly, ATU is not to compensate for poor methodological skills. It will not take up slack in the method. AST today requires many more skills than it used to in the old days. The ATU is defined by a single MIC value or a short range of zone diameter values, typically 1 to 3 millimeters. And the ATU will be handled differently in different laboratories, and depending on the situation and the urgency. It will depend on the sample, it will depend on the agent, it will depend on other agents and the susceptibility pattern at large. This is the same population as we looked at earlier for amoxicillin clavulanic acid in Enterobacterales, but now with the UCAST systemic breakpoint of 8 instead of the urinary tract breakpoint of 32. And as you can see, moving the breakpoint to the right in the disk diffusion test creates lots of problems. You have overlaps, you have some millimeter zones where you don't really know whether that particular result will represent a highly resistant organism or a susceptible organism. And you can see that the bars have lots of different colors within the same bar. The same problem now for Piperacillin tazobactam and Enterobacterales. When you look at this graph, it's no wonder we can't get it right most of the time, or rather sometime. The greens are to the right, the reds are to the left, and the yellows are in the middle. That's fine. But there is lots of overlap for each of those millimeter zones. When you remember that the precision of an MIC is ±1 dilution step at the best of times, a value of 16, which is intermediate, I category in the new terminology for Piperacillin tazobactam, this result may actually represent 32, which is resistant, or 8, which is susceptible. So that is a difficult area, and the same for the disk diffusion test. UCAST introduces an ATU from 17 to 19 millimeters, and what it tells you is that if you end up in that area, or with an MIC of 16 in an MIC test, you should actually take steps to ascertain the correctness of that test value and interpretation. In everyday life, in a normal clinical microbiology lab, it might look something like this. It will affect maybe 3 to 4% of your isolates, depending on where in the world you are. So some of the more important ATUs that we introduce in the 2019 table is, as I said then, amoxicillin clavulanic acid and Piperacillin tazobactam for Enterobacterales, also ciprofloxacin in the area of 0.5, 0.25, 0.5, Pseudomonas for Piperacillin tazobactam and for ceftazidime avibactam, Staph aureus for ceftaroline and ceftobiprole, and if you are on specific media, Staph epidermidis may throw up a difficulty in the cefoxitin screen test, which you may want to take care of with the PCR or simply report ATU as R. Haemophilus influenza is normally easy to test, with one exception. If you have a PBP3 mutation in your Haemophilus influenza, beta-lactam antimicrobial susceptibility testing becomes very difficult. Look at the flowchart in the UCAST breakpoint table, study it, and put together an algorithm that will work in your lab. So this is the new breakpoint table. The old columns are still there, S and I and R. Well, S and R and I is in between. And we've added 2 columns, one for MIC ATUs and one for zone diameter ATUs. You may have a zone diameter ATU without an MIC ATU and vice versa, or you could have, as for Piperacillin tazobactam, an ATU which is both an MIC and a zone diameter ATU. So what can you do when you end up in the ATU? You can repeat the test, but that is really only valid if you can spot a mistake in your primary test. The wrong disk, wrong inoculum, something to make you uncomfortable with the result from a technical point of view. You could confirm your result by using an alternative test. So let's say you end up in 17, 18 millimeters on a piperacillin tazobactam disc diffusion test, and you perform an MIC and you get an MIC of 16. You now have two different tests, both of which indicate that the isolate is I, belongs to the I category. And I think in that case it's absolutely bona fide to report an I. You could report the result because you don't really know what to do, but then add a comment stating the uncertainty, the uncertain interpretation, so that the clinician is warned that this result may not be absolutely fine. You could downsize the interpretation, so if you end up with an S in the ATU, you could downsize to I, or if you end up with an I in the ATU, 17, 18, 19 for piperacillin tazobactam, then to downsize to an R. Or you could just phone the clinician if it's important and discuss the result with him or her. I think it's fair to say that you should make an effort if there are only few alternative antibiotics available for therapy and one of them ends up in the ATU. Or if you're in a positive blood culture or another serious infection, then you should probably also make more of an effort. And also, if there is an easy win, there's an easy alternative by which you can confirm the result, then by all means do that. But if there are many alternative therapeutic alternatives, then maybe just report blank and add a standard comment about the uncertainty of interpretation. And should the clinician phone you up to have a discussion, fine. Both of you will learn something new. So thank you very much. If you have questions, you can address them to any one of the EUCAST Executive Committee. Our names plus eucast.org. The presentation can be downloaded. It can be used without specific permission for educational purposes, and you are free to use it as you see fit. Thank you so much.